Alright, so last time we talked about how the sun influences climate by heating the air and making wind, and also by heating the ocean and making currents, and how the currents affect the climate. But there are smaller things, like smaller than the sun and ocean currents, that can also have big impacts on an area's climate. One thing is the land-to-water ratio. So something that we see is the southern hemisphere has a lot more water than the northern hemisphere. Like 81% of the southern hemisphere is water compared to 61% of the northern hemisphere being water. So what are some effects you might expect to happen? What type of climate effects do you think would happen, or that do happen, between the northern hemisphere and the southern hemisphere, like comparing them? Which one do you think is going to have more rainfall? Since the southern hemisphere has more water, they're going to have more rainfall. Which one do you think has a more varied temperature, so it goes higher and lower? That's going to be the northern hemisphere. So you have more variation because you have less water. Water, we talked about it a while back, like it takes a lot of energy to change the temperature of water. It takes a lot of energy to evaporate water. Water gives off a lot of energy when it cools down. And so water really modulates the temperature. It keeps it from getting too high or too low. It keeps things very in the middle. Another thing that has a big impact on your climate is your proximity to the coast. So water has this big impact on temperature and precipitation. And so if you are closer to the coast, your climate is going to be less varied. You're not going to have extreme summers and winters the closer you are to the coast. Even if your latitude, longitude says, like if your latitude says you're up higher, you still might have a more mild winter than someplace that is further inland. And that's because the coast modulates that. You're also going to see a lot more rain. So think about like Washington, like Seattle, right? It rains a lot. The temperature stays pretty constant. There's not a lot of really cold, really hot. It's just kind of a mild climate with a lot of rain. Versus if you think of like, Montana, maybe not so much rain, definitely much colder winters, warmer summers, because they don't have the ocean to modulate that. And then, of course, mountains influence the climate. Like the mountain itself has its own climate, depending on how tall it is. As you go up, you're going to get cooler. But also, mountains cause things called rain shadows. And so here you can see water warming up with this warm wind, evaporating into this warm wind. As that air comes up the mountain, it cools off. We know as that air cools off, it's going to drop its moisture. And so you have precipitation as you go up the mountain. And then on the other side, well, it has lost all that moisture, so it's going to be a lot drier. And so you see these rain shadows on the leeward side of the mountains where it's going to be a lot drier. If you look at our continent and we have the Rocky Mountains, like on, well, maybe a better example would be the Sierra Nevadas. So they're like right there on the coast, running down Washington, Oregon, California. On the west side of that, you're going to have a lot more rain. When you get to the east side of that, you get into Nevada, Arizona, much drier climates, even though they are like right beside each other in the latitude, because you get on that leeward side of the mountain and it has already dropped all of its water, so you get very little precipitation over here on this arid side. A thing you might not correlate with climate is the soil. So how does climate influence soil? In a couple different ways. One way is it influences what plants can grow there, right? How much rain you get can also influence the soil. The soil is just a layer of chemically and biologically altered materials that overlies the bedrock. And so you have this unaltered parent material that over time gets eroded or weathered, and you get from your R horizon to your C horizon, where you have a lot of stuff that's kind of like broken up, just large rocks off of this parent material. And then you get to the B horizon, where it's pretty similar to the parent material because it's where it came from, right? Lots of clay minerals and oxides, things that get leached out from up here. So as water moves through the soil from the top down, things get dissolved into that water, and then it gets deposited down here in this B horizon. The E horizon, this is the soil that has been leached of those minerals. So as it comes through here, it's sucking out the minerals and then deposited here. The A horizon, this is going to be a rich humus consisting of decayed organic material, different parts of plants, animals, stuff that has turned into like that really nice earthy mix of soil. And then O is going to be primarily dead organic litter. So the stuff right on the top, dead grass, dead leaves, that kind of stuff, okay? So the parent material is going to be the bedrock. And the type of soil you have is going to be based off of this bedrock, but also what type of climate you have. Because the climate can influence the plants. The plants then influence the parent material, influence the soil. The rainfall leaches different amounts of minerals from the soil. And so climate has a big impact on what type of soil you have. And so ways that it does that is with your dry climates, you're going to get very little weathering. There's not a lot of snow, there's not a lot of rain, there's not a lot of water to beat the rock apart. And so you end up with really thin, shallow soils versus wet climates like a tropical rainforest where you get a lot of rain, you get a lot of plant growth, you can build up a lot of soil, up to 100 meters deep of soil going down. Typically, like where we live, you're going to get around a meter of soil. It's about 3 feet of like nice, good soil. And then the deeper you dig, you'll start getting into the B horizons, even maybe the C horizons. Alright, two things that we see on climate and soil is lateralization and podsilation. Lateralization, this is something you're going to see like in the tropical rainforest. It's where you get a lot of rain. So as you get a lot of rain, you're going to get a breakdown of these clay particles, and you're going to get leaching of silicon from the soil. And so that leaves iron, calcium, sodium, silicon. Or it leaves iron and aluminum up here while the calcium, sodium, and silica get down here into the C horizon. And in podsilation, you're going to have some iron and aluminum coming down through the E, but stopping at the B horizons. And then your calcium, potassium, sodium moving down closer to that C horizon, getting down into deeper into the B horizon. And this is because you're going to see this like in evergreen forest and fir forest, spruce forest. Those pine needles drop and they produce really acidic environments and that rainwater filtering through there picks up those hydrogen ions and pulls these soluble nutrients, these minerals, from this layer to deposit them further down. So in tropical, you have mostly iron and aluminum up here in the E horizon. And look how big that E horizon is. It's really large compared to other places. It has like no B. You just get a blending of the E and it goes down to the C. Versus in your podsolation, you have solid E's and B's. Okay, so what are the different soil horizons and what are they composed of? So looking back here, right, or here, you have your O, organic, your A, partly decayed organic material with some mineral soil, E, leached minerals, B, where that leached stuff ends up, so where it gets deposited, C, broken up parts of the parent material, and R, the parent material. How do rain shadows cause desert formations? As that comes up, it drops the water, and then as it comes down on the other side, you're going to have dry areas like deserts. How does continental landmass influence the amount of precipitation? Think about that northern hemisphere versus southern hemisphere. Which one has more water? Which one gets more rain? Which one has more varied temperatures? For the El Nino oscillations, what causes the oscillation? Change in the wind currents, blowing that warm water back towards the coast instead of away from the coast. And then given the position of a solar equator, so as that sun moves, what does that suggest about the local intertropical convergence zone, so where those Hadley cells come together throughout the year? They're going to move with the sun, right? All right. We're going to talk about biomes in the next one.